Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous 5 videos, I solved ETA MCQs of Engineering Test of Mathematics portion of 2019. In today's video, I am going to start with exercise number 5.3, chapter number 5, Integration or Antidifferentiation, FSC Part 2 Mathematics. So the first question of exercise number 5.3, chapter number 5, Integration is totally related with the indefinite integration by the method of partial fraction decomposition. So let's move toward exercise number 5.3, Mathematics FSC Part 2 Integration, chapter number 5. Question number 1 tells that evaluate indefinite integrals after decomposing the following rational functions into a partial fraction. So the first part is 1 over x into x minus 3. So this is actually the single fraction. Remember, partial fraction is that phenomena in which we convert a single fraction into two or more than two fractions. So over here, this single fraction will be converted into a two fraction, and then we will integrate that required decomposition. So we can write it in the form of 1 over x into x minus 3, apply indefinite integral, and over here we have dx. Now this is actually x is linear factor because the highest power is 1. So we'll write a single constant a divided by x plus, and x minus 3 is also linear factor, so we'll write another constant b divided by x minus 3 into dx. Now first we are going to find the value of this a and b. So 1 over x, using the partial fraction method, 1 over x into x minus 3 is equal to a divided by x plus b divided by x minus 3. Multiply x into x minus 3 to the both sides. So on this side we left with 1, and on this side we left with a into x minus 3 and plus b into x. Now from over here, x is equal to 0. So by putting x is equal to 0 over here, so this term cancel out. Over here by putting x 0, it becomes minus 3a is equal to 1. So the value of a is minus 1 by 3. Now from over here, x minus 3 is equal to 0. So the value of x will be 3. By putting x3 over here, it gives us 0. And by putting x3 over here, it becomes 3b is equal to 1. So the value of b will be 1 by 3. Now by putting these two values in the given indefinite integral, it becomes indefinite integral of a by x. So a is minus 1 by 3 divided by x. b is actually 1 by 3, so we'll write 1 by 3 over here and divided by x minus dx. Now minus 1 by 3 is a constant, so we'll write it outside of the integral. Inside we left with 1 over x dx, and 1 over 3 is a constant, so we'll write it outside of the integral and apply the integral on 1 over x minus 3 into dx. Now it becomes minus 1 by 3, integral of 1 by x is ln of x, and plus 1 by 3, integral of 1 by x minus 3 is actually ln into x minus 3 plus constant of integration. Now from over here we can also simplify it further. Minus 1 by 3 will move to the power of x according to the logarithmic formula, so it becomes ln of x power minus 1 by 3, and over here 1 by 3 will move to the power of x minus 3, it becomes ln of x minus 3 power 1 by 3 plus constant of integration. Now this x power minus 1 by 3, this can be written as 1 divided by x power 1 by 3. Because the power is negative, so by moving to the denominator it becomes positive. So 1 over x power 1 by 3 can be written as 1 over cube root of x. So it becomes ln of 1 divided by cube root of x. After this, it becomes ln of this 1 by 3 can be written in the form of cube root, so it becomes cube root of x minus 3 and plus constant of integration. Now over here we have a formula generated, ln of a plus ln of b, which is equal to ln of a into b. So it becomes ln of a. A is actually cube root of x minus 3 divided by cube root of x. So cube root of x and plus constant of integration. Now we can write it in the compact form. So it becomes ln of x minus 3 divided by x and taking the cube root on both of them and plus constant of integration. So this is actually the required and desired answer. Now move to the next question, part number b. It tells that 3x square plus 2x minus 1 divided by x into x plus 1. Integrate this function by the method of partial fraction. So remember that we will first simplify the denominator. So x multiply x gives us x square, x multiply 1 gives us x, and the numerator will come down as it is. Now over here, this fraction is actually improper fraction. So improper fraction cannot be integrated directly. So we will first divide them by each other. So 3x square plus 2x minus 1 inside and outside of in the divisor we will write x square plus x. In the divided we will write 3x square plus 2x minus 1. So x square multiply 3 will give us 3x square. They will cancel out with each other. X multiply 3 will give us 3x. So the sign will be changed. It becomes negative x and minus 1. So the writing method is actually the quotient plus remainder divided by divisor. So now after this it become take out negative common, so it become negative multiply plus, it gives us negative, and it become x plus 1 divided by x square plus x. So now we can integrate this function because this is actually the proper fraction. We convert this improper fraction into a proper fraction. So improper fraction can be integrated directly. So it become integral of 3 minus x plus 1 divided by x square plus x into dx. So multiply 3 with dx, so it become 3 dx. So and multiply take the integral on this term separately, so it become minus into integral of x plus 1 over x into x plus 1 dx. X plus 1 cancel out with x plus 1, we left with 3. We will write 3 outside the integral because this is a constant. Inside we left with 1 into dx minus, so x plus 1 cancel out with x plus 1, we left with 1 over x into dx. Now the integral of 1 is always equal to the variable x. So because over here the operator is dx, so we will write x. So because if we differentiate x with respect to x, it will give us 1 again. And over here minus time of integral of 1 by x is always ln of x plus constant of integration. So this is actually the required and desired answer. Now move to the next part of part number C. It tells that 4x cube plus 4x square plus x minus 1 divided by x square into x plus 1 whole square. Integrate this fraction. So over here x square is actually the quadratic function, so it means that the solution must be 2. So we will write 2 constant ax plus b divided by x square. Now over here this x plus 1 is a linear factor, so we will write a single constant c divided by x plus 1. But remember one thing over here we have whole square, so we will write again another constant, so d divided by x plus 1 whole square into dx. So now after this multiply x square into x plus 1 whole square on the both sides, so x square into x plus 1 whole square will cancel out. On this side we left with 4x cube plus 4x square plus x minus 1. By multiplying x square into x plus 1 whole square, over here we left with x square is cancelled out with x square, we left with x plus 1 whole square into ax plus b. By multiplying x square into x plus 1 whole square with this term, we left with cx square into x plus 1. By multiplying x square into x plus 1 whole square with this term, we left with dx square. Now from over here I is supposed to be taken x is equal to 0. So by putting x is equal to 0 in this equation, we will get the value of b is equal to -1. From over here x plus 1 is equal to 0, so we will get x is equal to -1. By putting x is equal to -1 in this equation, we will get the value of d is equal to -2. Now we need with the value of a and c to integrate the given function. So the given equation is 4x cube plus 4x square plus x minus 1, x plus b, x plus 1 whole square gives us x square plus 2x plus 1, cx square multiply s gives us cx cube, cx square into 1 gives us cx square, and plus dx square. Now after this, by simplifying, it will give us 4x cube plus 4x square plus x minus 1 is equal to ax cube plus 2ax square plus ax plus bx square plus 2bx plus b plus cx cube plus cx square plus dx square. Comparing the coefficient of x cube on both sides of this equation. So over here the coefficient of x cube is 4, the coefficient of x cube is a, and the coefficient of x cube is c. Let's suppose this is first equation. Comparing the coefficient of x square in this equation, x square coefficient is 4, the x square coefficient is 2a, x square coefficient is b, x square coefficient is c and d. This is, let's suppose, second equation. Comparing the coefficient of x in this equation, so we will get 1 is equal to a plus 2b. So putting the value of b is present, so we'll put b is equal to -1, so we'll get the value of a is equal to 3. Now by putting the value of a is equal to 3 in equation number first, so a is 3, so we will get the value of c is equal to 1. Now by putting these 4 value over here, it become ax. So a is 3, it become 3x, and b is a -1, so it become 3x by -1 over x square. Take the integral on all of these 3 terms separately and ln. So c by x plus 1, c is actually 1, so 1 over x plus 1 plus d by x plus 1 whole square. So our d is actually -2, so -2 by x plus 1 whole square. 3x by x square gives us 3 by x, minus 1 by x square will give us -1 into x power -2 dx, and plus 1 over x plus 1, minus 2 will come out of the integral, so it become -2. X plus 1 whole square will move to the numerator, it become x plus 1 power -2. Now by integrating this function, it gives us 3 ln x, it will give us minus x power -1 over -1, it will give us ln of x plus 1, and integral of this will give us -2 x plus 1 power -1 over -1. By simplification, our required result will be 3 ln x plus 1 by x plus ln of x plus 1 plus 2 by x plus 1 plus constant of integration. This is the required result. Now move to the next part of part number D. It tells that 1 over x cube minus 1 into dx. Integrate this function. So using a cube minus b cube is equal to a minus b into a square plus ab plus b square. Over here the value of a is x and the value of b is 1. Putting in the formula, it becomes x cube minus 1 a is x minus 1 into a is x square, a is x and b is 1, it gives us x and b is 1, it gives us 1. So our x cube minus 1 is actually equal to x minus 1 into x square plus x plus 1. After this x minus 1 is actually the linear factor, we will write a single constant a divided by x minus 1. And this factor is actually the quadratic factor because the highest power of the variable x is 2. We will write 2 constant bx plus c divided by x square plus x plus 1. Now after this, so multiply x minus 1 into x square plus x plus 1 on the both side. On this side we left with 1. On this side we left with a into x square plus x plus 1 and bx plus c into x minus 1. Now from over here x minus 1 is equal to 0. So we will put the value of x is equal to 1. So by putting the value of x is equal to 1 in this equation, it becomes the value of a will be actually 1 by 3. Now comparing the coefficient of x square on the both sides. So over here the coefficient of x square is a and the coefficient of x square is b. And on this side, on the left hand side, the coefficient of x square is 0. So it becomes b is equal to negative a. A is 1 by 3, so by putting a is 1 by 3, so the value of b will be negative 1 by 3. Now after this, so we are going to find the value of c. So for finding the value of c, we will compare the coefficient of constant on the both side. So on this side the constant is 1, so we will write 1. On this side the coefficient the constant is a and the constant is c, so it becomes a minus c is equal to 1. So by rearranging, it becomes c is equal to a minus 1. A is 1 by 3, so 1 by 3 minus 1 will give us minus 2 by 3. It is actually the required value of c. Now by putting the value of a, b, c over here, it becomes a is 1 by 3 over x minus 1, b is minus 1 by 3 into x and c is minus 2 by 3 divided by x square plus x plus 1. 1 by 3 will come out outside of the integral, and we will integrate 1 over x minus 1, and over here minus 1 by 3 is outside of the integral. We left with x plus 2 over x square plus 1 dx. After this integral of 1 over x minus 1 is ln of x minus 1 multiplying and dividing with 2, it become minus 1 by 6 multiplying 2, so 2x plus 4 over x square plus x plus 1. Now after this I will solve this further. Now solve it further. So 1 over 3 ln of x minus 1 will come down as it is, minus 1 by 6 will come down as it is, 2x plus 4 can be written as 2x plus 1 plus 3. So split 4 into 1 plus 3, so it become minus 1 by 6. So 2x plus 1 over x square plus x plus 1 and plus 3 over x square plus x plus 1, and take the indefinite integral on both of them. So 1 over 3 into ln of x minus 1 minus 1 by 6. So now if I consider x square plus x plus 1 is equal to t and take the derivative on the both sides, so our dt will be 2x plus 1 into dx. So 2x plus 1 into dx is dt, and x square plus x plus 1 is supposed to be taken t. And plus over here 3 multiply minus 1 by 6 will give us minus 1 by 2, and 1 over x square plus x plus 1 dx will come down as it is. 1 over 3 into ln of x minus 1 by 6 ln of x minus 1 minus 1 by 6, so it become 1 over t integration is ln of t minus 1 by t integral of, over here we are given with x square plus x plus 1, so we cannot integrate it directly. So over here we will make the perfect square formula, either a plus b whole square or either a minus b whole square. So over here we need 2x in the formula, x square plus 2x or x square minus 2x. So I will multiply and divide with 2, so it becomes 2 into 1 over 2 into x. Plus 1 will come down as it is. Now the square of 1 by 2 is actually 1 by 4. So I will add and subtract 1 over 4 and minus 1 over 4. So it becomes 1 over 3 into ln of x minus 1 minus 1 by 6. Ln of t is actually x square plus x plus 1 minus 1 by 2 integral of, over here the formula generated a square plus 2ab plus b square gives us a plus b whole square, and 1 minus 1 by 4 gives us minus 3 by 4. I solve it further to the required solution. Now after this step we will get 1 over 3 into ln of x minus 1 by 6 into ln of x square plus x plus 1 minus 1 by 2. Over here x plus 1 over 2 whole square will come down as it is. 3 by 4 can be written as square root 3 by 2 whole square, because square can start with under root, we left with 3, and 2 square will give us 3 by 4 again. Now after this, using the formula 1 over x square plus a square integration is 1 over a tangent inverse x by a. So these two steps will come down as it is, and minus 1 by 2 will come down as it is. 1 over, let's suppose this is x and let's suppose this is a. So x square plus a square formula will use, which is equal to 1 over a. A is 3 by 2, so 1 over square root 3 by 2 tangent inverse x by a, as x is x plus 1 by 2 divided by a square root 3 by 2. Now this 2 will move to the numerator, it become minus 1 by 2 into 2 by square root 3 tangent inverse. This 2 will move to the numerator, multiply with x plus 1 by 2, and square root 3 will come down as it is. So it become minus 1 by square root 3 tangent inverse 2 multiply x gives us 2x. So 2 can start with 2, we left with 1 divided by square root 3. So the required and desired answer will be 1 over 3 into ln of x minus 1 by 6 ln of x square plus x plus 1 minus 1 upon square root of 3 tangent inverse of 2x plus 1 divided by square root of 3 plus constant of integration. This is the required answer. Now move to the last part of today's lecture and the last part of question number 1 of exercise 5.3 part number E. It tells that integral of x power 4 minus x square plus 2 divided by x square into x minus 1 integrate this fraction. So over here x minus 1 is a linear vector, we will write a single constant a. X square is a quadratic vector, we will write bx plus u over x square. Now after this multiply x minus 1 x square on the both side, we left with x power 4 minus x square plus 2. On this side multiply x minus 1 into x square. So x minus 1 cancels with x minus 1, we left with a x square and bx plus c multiply x minus 1. Now after this multiply them and simplify them and take the coefficient of x square common from one end, we left with a plus b. The coefficient of x is take out common, so we left with c minus b and minus c. Now from x minus 1 we will put it is equal to 0, so the value of x will be equal to 1. By putting x is equal to 1 in this equation, it will give us a is equal to 2. Comparing the constant in this equation, so the constant on this side is 2 and the constant on this side is negative c, so the value of c will be negative 2. Comparing x square coefficient on this side is negative 1, on this side the coefficient of x square is a plus b. So by putting the value of a from over here it becomes b plus 2, so the value of b will be equal to negative 3. Putting these three values in this integral, so it becomes 2 by x plus x minus 1, b is actually negative, so negative 3x, c is actually negative 2 divided by x square. So 2 divided by x minus 1 integral is actually 2 ln of x minus 1. It becomes minus 3x by x square gives us minus 3 by x, and minus 2 by x square can be written as minus 2 into x. It move to the numerator, it becomes x power negative 2. So 2 into integral of 1 over x minus 1 is ln of x minus 1. Integral of 1 by x is ln of x. Integral of x power negative 2 is x power negative 1 over negative 1. By simplification, it will give us 2 ln of x minus 1 minus 3 ln x. Minus into minus gives us plus 2. X minus 1 will move to the denominator, it become x. So 2 by x plus constant of integration. This is the required answer. So with this question I finish my lecture. Inshallah in the next video I will solve question number 2 of this exercise number 5.3 KPK board. So thank you for watching, subscribe my channel and also hit the bell icon to receive the upcoming notification about FSC part 2 mathematics. Thank you.